All right, so that's section 1.7 kind of ties into section 1.6. 1.6 was about the center. So another way that we describe a distribution is by its variability. Okay, now the variability portion, I think people get confused. So again, the key word is varies, right? You're measuring how the data varies. And when you do any type of experiment or sampling, you're really looking at, is everything pretty much spot on, or is there variability, especially in like quality control and like manufacturing, right? If I say I want a cereal box to have, 18 ounces of cereal, I would like everything to be right around 18 ounces. I don't want 12 ounces in one and 30 ounces in another one, right? That'd be high variability. So again, think of variability as the spread, right? So variability is just how spread the data is. So keep that in mind. Variability means spread. Okay, so there are 3 ways to measure variability, okay? And the reason we have 3 ways is because of how each of them is impacted by the data. So 2 distributions can have the same shape and center, but still look quite different due to variability. So let's talk about these 2 dot plots. So I would say that the center is right around here. I'm going to draw right around the peak. So this is the center. And I would say both are roughly symmetric. So if you remember, roughly symmetric is that bell shape kind of, right? Where the right side and left side kind of look the same. Same thing here, right? Right side, left side look the same. So roughly symmetric. So I'm just writing the shape up there, roughly symmetric. 2 M's, sorry. I'm trying. Roughly symmetric. That's symmetric. However, look at the variability, right? Earl's bowling scores go from around 50 all the way to like 250. So, Earl can really throw a bunch of gutter balls, but, a couple times, man, he almost got a perfect game, right? Whereas Kelly, she goes from about 100 to 200. So her spread is a lot less than his spread. His spread is 200 points or pins. Her spread is only 100 pins, right? So she's a lot more consistent around the middle, whereas, Earl can have a really bad game and a really good game. So what I'm demonstrating is the range, right? The range is the distance from the smallest value to the biggest value, right? We're also going to talk about the interquartile range and the standard deviation. The standard deviation is the one that we talk about the most. Again, in the future chapters, most of the time we're working with the mean, and the variability that ties in with the mean is standard deviation. Okay. All right, so again, the range is very simple. It's the max value minus the minimum value. Again, the range is not resistant. If you remember resistance is the idea that the high and low values don't affect you. But that doesn't make sense because the range depends on the high and low values, the maximum minimum values, and those could actually be outliers. So that should make sense to you. So typically we don't use the range to describe the variability of a data, okay? Again, the other problem is down here, you cannot measure the variability from the center. This little phrase, the variability from the center is unclear. So if you look at this parallel dot plot, both of them have the same range, right? It goes from 68 all the way to 72. So 72 minus 68. So the range is 4 millimeters. But if I was a company, which of these dot plots would I appreciate more? Well, if my target is 70, I would appreciate A lot more because there's a lot more at 70. If you look at B has a lot more data points that are away from the middle. So to me, B would be more variable, but you wouldn't tell that by using the range. So be aware of the range is not always the best thing to use. It is the simplest, but not always the best. So then the next thing to talk about is interquartile range. And to talk about that, we need to talk about what are quartiles. So if you think of quartiles as quarters, quartiles divide the data into 4 groups, having about the same number of values in each group. So we already talked about the median. The median is the middle value. It's the middle or the 50% value. So like half the data is below, half the data is above. But then we have what's called the first quartile, or Q1, and third quartile, which is Q3. And the first quartile is the median of the lower half of the data, and it represents the first 25%. So from the minimum value up to it is 25% of the data. Then you have the third quartile, which is the median of the upper half of the data. So from the minimum up to the third quartile is now 75%, 3/4. So now to find your interquartile range, or your IQR, you're going to take the third quartile minus the first quartile. And what that's going to give you is that's going to give you the middle 50%. So this will give you the middle 50%. And that's another way to kind of talk about the spread, right? We look at what is the range of the middle 50%. So we don't think about the low values that might be outliers, or the high values that might be outliers. We think of where the majority of the data is in that middle 50%. And again, notice that the quartiles and the interquartile range are resistant. They go along with the median. The median is resistant because it's the middle value. Those outside values aren't really taken into account. Same thing with the interquartile range. The interquartile range is more close to the middle, so it doesn't rely on those outside values. So here is a visual representation of a dot plot with quartiles. So here's your first quartile, your median, which is your second quartile, and your third quartile. So this is the first 25%. This is the second 25%. This is the third 25%. And this is the fourth 25%. If you look at the dots, there's 3 dots, then 3 dots, then 3 dots, then 3 dots. Exactly the same number of dots in each section. And the interquartile range involves the third and first quartile, this value and this value. So from here to here is the interquartile range. And that again is the middle 50%. All right, so let's see if we can do a problem involving the IQR. Oh, sorry about that. Erase. Okay. Sorry. Okay, so it's example 1, a healthy range to choose from. Here are the data on the amount of fat in grams in 9 different McDonald's fish and chicken sandwiches. Find the interquartile range and interpret this value. Okay, so to do this, we need to go to our stats applet. Again, you could arrange them yourself, but we're going to let it do it for us. I'm more worried about the interpretation. So I took a picture. Feel free to listen to me as I go through. So I'm going to go stats applet. This is one quantitative variable. Again, I don't really care what the variable represents. Right now, I'm just going to type in the data. So 19, 16. If I was making a dot plot or something, I would care. 22, 33, 27, 9, 20, 14, and 19. So there are my 9 numbers. Begin analysis. There were 9 numbers. And now down here, notice in your summary statistics, it tells you everything you need to know. To find the IQR, I need Q1 and Q3, 15 and 24.5. So back here, so to find my IQR, I need my Q1, my first quartile, which was 15, and my third quartile, which is 24.5. Again, notice neither of those are values in our data set. So to find the IQR, we take the third quartile minus the first. 24.5 minus 15, and that is 9.5, and that would be grams. So now we're going to interpret this value. So we will say that the range, it is a range, the interquartile range, the range of the middle, and I use the word half, but you could say 50%, the middle half, half. The range of the middle half of the fat in the sandwiches is 9.5 grams. And there we go. Wow, that was a big old circle. So use that terminology when interpreting the IQR. All right, sorry for the longer video. One more video coming about standard deviation.